Have you ever just felt like you're drowning in data? You're not alone. It's a super common problem. But what if I told you there's a pretty straightforward process to turn all that chaos into real clarity? Well, today we're going to tackle that fundamental skill, organizing quantitative data. This is the step, the one that turns a messy pile of information into an absolute powerhouse of insight. You know, this quote just nails the problem, doesn't it? Get this. A horse racing enthusiast had literally 5 bins of race results sitting in his basement, but he had absolutely no clue what to do with them. It just proves a crucial point, right? Collecting the data, that's actually the easy part. The real challenge, and where all the good stuff is hiding, is in making sense of it all. And that really brings us to the core issue, the problem with raw data. Here's how I like to think about it. Imagine your room is an absolute mess. All your favorite things might be in there somewhere, but it's completely useless until you sort it out and put everything where it belongs. Well, guess what? The exact same principle applies to your data. And this right here, perfectly frames our goal for today. We're going to go on a little journey from the chaos you see on the left, the bins in the basement, to that organized clarity on the right, where our data becomes genuinely insightful and totally ready for analysis. So think of this explainer as the roadmap that's going to get us there. So, how do we start? Where do we begin this journey? Well, it all starts with just a little bit of planning. Now, I know, it might seem like a small, skippable step, but trust me on this one. A few minutes of strategic thinking right now is going to save you hours. I'm not kidding, maybe even days of headaches later on. Okay, first things first. Before you type a single thing, just take a second and look at your survey or your data source. Just think logically. You don't have to enter the data in the exact same order you collected it. For instance, go ahead and group all those demographic questions, age, gender, race, together in your spreadsheet. This one simple step creates a logical flow that makes the actual analysis so much smoother. Next up, choose your software. And you've got plenty of options, from a simple Excel spreadsheet to really powerful statistical packages like SPSS or R. But here's the crucial tip, and please listen to this one. Think ahead. Make sure the program you use to enter the data can easily export to the one you're going to use for analysis. A simple compatibility check right now can prevent a corrupted file and a total meltdown later on. Okay, so our plan is in place, and now we're diving into the real heart of the process. This is the fascinating part, really, where we take all those human answers, all the words, the opinions, the categories, and we translate them into this clean, consistent numerical language that computers actually need for analysis. All right, before we type a single piece of data, we have to follow 2 non-negotiable ground rules. Rule 1, every single case, whether it's a person or a survey, gets its own unique ID number. This always goes in the very first column. Rule 2, and this is a critical rule of ethical research, you never use real names or any personal identifiers in your dataset. Protecting anonymity is absolutely fundamental. Now, this whole process of turning words into numbers, it's called coding. And don't worry, this has nothing to do with computer programming. Think of it more like you're creating a secret code for your data, a really simple, consistent number system that lets you perform calculations and ultimately uncover all those hidden patterns. And here's exactly what that coding looks like in practice. See? Instead of typing out female and male hundreds of times, we just use 0 and 1. Simple. On an opinion scale, strongly disagree might become a 1, while strongly agree becomes a 4. It's all about making the data simple, efficient, and perfectly consistent for the computer to understand. So as you start coding, you'll notice that your variables come in a few different flavors. First up, we've got nominal variables. Now with these, the numbers are basically just labels. That's it. If 1 equals blue eyes and 2 equals brown eyes, it doesn't mean brown is somehow more than blue. They're just different categories. That means you can count how many people have blue eyes, but you can't do math like calculating the average eye color. I mean, what would that even be? It just wouldn't make sense. Next, we've got ordinal variables. Okay, these are a step up because the numbers do have a meaningful order. A 4 for strongly agree is definitely a higher level of agreement than a 1 for strongly disagree. But here's the catch. The distance between each number isn't necessarily equal. The jump in how you feel from disagree to neutral might be totally different than the jump from agree to strongly agree. And finally, there are numerical variables. This is the stuff we're all familiar with, things that are already numbers and have a true mathematical value, like your age in years or your height in inches. With these, the intervals between the numbers are equal and they're meaningful, so you can do all the standard math you want, like addition or calculating an average. Understanding whether your data is nominal, ordinal, or numerical is absolutely crucial because that's what's going to dictate the kind of statistical analysis you can even run later on. And after all that planning and coding, this is what you get. Look at that, a clean, logical grid where every single row is a case, every column is a variable, and every number has a purpose. It's beautiful, isn't it? This is our clarity. But hold on, there's one final critical piece we need to make sure it all stays this way. So, you've created this perfectly coded data set. That's fantastic. But what happens if you step away from it for a week, or a month, or a year? How on earth are you going to remember if 1 in the gender column meant male or female? Or what if 4 in that opinion column really means? You're going to need a key. That key is called a codebook. Think of it as your data's very own instruction manual. It's a separate document, and it lists every single variable and explicitly states what each numerical code stands for. And I really can't stress this enough. Without a codebook, your perfectly organized dataset can turn into a meaningless grid of numbers shockingly fast. It is absolutely essential. Honestly, the best way to think of a codebook is as the Rosetta Stone for your data, right? Just like that ancient stone unlocked the meaning of Egyptian hieroglyphs, your codebook unlocks the meaning of your data. For you, for your colleagues, or for any other researcher who might use it years from now. Okay, one last super practical tip for you. People are inevitably going to skip questions. It just happens. That leaves you with missing data, and you need a plan for it. You can either just leave the cell blank, or you can use a specific number that's way outside your normal range, something like 9999, to show that there was no response. Whatever you choose, the most important part is to write it down in your codebook. And there we have it. We've journeyed from a basement full of chaotic paper all the way to a clean, logical, and truly meaningful data set, complete with its own Rosetta Stone. Your data is no longer just a collection of random numbers. It's a library, and it is full of stories just waiting to be told. So the only question left is, are you ready to start reading?